Hello, we are Sabrina Quirarte and Montserrat Peña, and today we're going to talk about key concepts or general concepts of probability. We will explain the laws of probability, give some classical examples, and solve them with different procedures.
Probability is the extent to which something is probable or the likelihood of the occurrence of an event. Sample space are all possible outcomes called universe set or all possible subsets called the power set.
So for probability, we have some classical examples. To start with, we have the coin one. It's where you can always flip a coin 1, 2, 3, 4 n times. So for the first case, you're flipping a coin once. So your sample space is only head and tails. Therefore, you make what is the probability of getting one head? It is equal to 1 over 2 possibilities. Or getting 0 heads, it is 1 over 2 possibilities. Therefore, applying the laws of probabilities, you sum this probabilities of heads and tails, and it would equal 1. On case 2, you flip a coin twice. Therefore, your sample space would be head head, head tails, tail head, and tail tails. For the probabilities, you do the same. You make probability of getting 2 heads, it is 1 over 4 possibilities. The probability of getting tails tails, it is 1 over 4, and the probability of getting head tails or tail heads, which is the same, it would be 2 over 4. And applying the law, it would be the addition of all this, which will equal to 1.
For this example of probability, we have to roll one die. In this case, our sample space would be of 6. Therefore, each probability for each number would be 1/6. Random experiment is the process by which we observe something uncertain. All values for the sample are determined by chance or opportunity. Dependent events are one that influences the probability of another event. An independent event is an event that has no connection to another event, chances of happening or not happening.
Then, another of the different concepts that probability involves is the outcome, which is all of the results from the experiment or the probability experiment you've done. So with all these concepts, we can go then to the properties of probability, where here are involved the concepts of intersection union and the independent and dependent variables that we have seen. In intersection, here is a symbol. It's like a U but in reverse. An intersection is the ones that are shared only, okay? So in a sample space, the intersection always only involves the ones that are shared. In the case of the union, the symbol that the union represents is like a U. Then a union means the addition of probabilities and the subtraction of the intersection. So in a sample space, the union is everything except from the intersection. So you have to subtract that once you get the union. Then the properties are every probability of an event less than 1 and less than 0, PE always stands for probability of an event. That's one law. Then also we have to remind always that the probability of 0 will always be 0, and the probability of a universe will be 1. So the second probability is the addition of every probability of an event will sum 1. In this case is what we saw here in the union. When we added everything, you have to subtract the intersection when necessary, if it's shown. If it doesn't, if you just have union, it is not necessary. Then the third property would be the complement one. So the probability of the complement of an event is equal to 1 minus the probability of the event. This probability refers to getting the probability of everything happening except from the event. Then we have also the laws of probability. The first law of probability involves union. When you always see this, or a problem gives you the word or, you have to remember that it will always mean union. Then, the probability of A union B is equal to the addition of the probability A plus probability B minus the probability of A intersection B, which will be the same as the probability that we saw here, the subtraction of the intersection. So, if the intersection of A and B is 0, then as said, you just have to do the addition of probability of A and B. You don't have to subtract the intersection because there is no intersection. And the second law is that if A and B are independent events, therefore P of A intersection B would be probability of A times probability of B. Then, for every time that it is shown this symbol, or a problem says and, the word and, you will always remember that it means intersection. So, one of the basic examples, or classical examples that we have for laws of probability or properties is this one. Imagine that you have people watching Netflix, which would be Andrea, Beatrice, Elisa, Peter, Hugo, and Joel. And also people who listens to music, which would be Carolina, Ivana, Beatrice, Elisa, Danny. And people playing video games, which would be Georgia, Mark, and Karen. So for this problem, first of all, they ask us which is the sample space. So in order to get the sample space, you have to do the addition of all the names that are mentioned here, except for the ones that are repeated, which would be Beatrice and Elisa in these cases. Apart from those, you just add them except from these two, and that would give you a total sample space of 12 people. Then, it asks you to draw a Venn diagram that represents the universe of this problem. So, you have to do a Venn diagram with the three different subjects or categories there are. You would introduce the people that are mentioned in each of the categories. For example, here Netflix, that involves Andrea, Peter, Hugo, Joel. The music, that only involves Carolina, Ivana, Danny. And video games, that involve Georgia, Mark, and Karen. So, as we saw later, well, as we have seen, there were two names that were shared, that were Elisa and Beatrice. So, as they were shared in music and Netflix, but not video games, they go in this part of the Venn diagram as they are being shared. Elisa and Beatrice. Here they are. Then, that is the Venn diagram of the universe that you have. In letter C, it asks for the probability of people watching Netflix. So, here we have 1, 2, 3, 4. And the ones that I've shared because they watch Netflix and also listen to music. So we have 4 here and 2 more. So that would give you a 6 out of 12, which is the sample space. You can leave it as a fraction or you can simplify it as 0.5. That would be your answer. Then in letter D, ask for the probability of music. In this case, we have 3 answers here, but we have to remember that they are being shared with Netflix. So we have to add these 2 more. So it would give you a total of 5 over 12. As I said, you can leave it like a fraction or you can simplify it. In letter E, it asks you for the probability of video games. So we have 3 names here, and as there is no other name being shared, that will give you a 3 out of 12 answers, or 0.25. And finally, it asks you for the addition of the probability of each of the categories that are being shown. So probability of Netflix, probability of music, and probability of video games. It asks you that if you add all of these, is it gonna be 1 as an answer? So you just have to make the probability of Netflix plus the probability of music and video games. And As said, as here there is an intersection, you just have to make it 14 over 12 minus 2 over 12, which give you 12 over 12, and simplified it is 1. So therefore, the question is right. It will always give you 1. That's the law of probability, that it always gives you 1. It must have a 1.
As a conclusion, we can say that probability is the measurement of the likelihood that an event will occur. By applying it to real life, we can make better and more informed decisions.
Thanks for watching!